This might possibly be the coolest broaching video on the internet, guys. I don't know. Welcome back. Quick recap. This is part 2 of a little 3-part series. If you want to get kind of spun up on what we were doing, you can go back and watch part 1. Part 1, we basically just made a part in Fusion. Nothing crazy about it. Nothing wild. Today, we're going to be making the bottom part, a mating part. And specifically what we're going to go over, right? The geometry is very similar. There's a few differences. The biggest difference is we're going to be broaching holes today. We're going to be broaching some 10 millimeter hexes into this part. It's very specific. It's something that I don't think a lot of shops are being asked to do very often. And more than that, I don't think that it's being done on CNC machines as often and or done through the post processor in a CAM software. So like today, Fusion 360, we're going to post this code. There's no hand editing. It's just going to broach. We're not using a macro like probably is the case 99% of the time when somebody's broaching in a CNC machine.
You don't broach, you keep your mouth shut.
So we're going to go hop into Fusion and we're going to go over these details. So building off of the last video, we're here. We're going to broach holes, hex holes for some 6 millimeter nuts. So from flat to flat, they end up being 10 millimeters across, roughly. So we started going down the rabbit hole of trying to create a custom macro to get this done. That proved to be a little bit challenging, right? And I didn't truly have my head wrapped around all of it. So I kind of abandoned that idea and I went back to the DSI guys who had initially helped me come up with like a broaching strategy through Fusion using a trace. As I've said before in past videos, I purchased my Fusion subscription and my Complete subscription through DSI, Design Software International. The huge advantage of doing that, right, is they have a whole team of experts there at that company. They give support and help. So you can put a call in, you can put an email in, you can message them on Instagram. They're a large company, but at the same time, they're still a small enough company to where they truly know who you are as a Fusion user, as a Complete user, right? Like they're onboarding you, they're helping you with any training, stuff like that. So when I came to them and said, hey, I have this funky part, I need this blind broach, I want to do it on the CNC machine, I want it to come off one and done, right? They're like, yeah, we'll come up with a solution, right? So they're the ones that helped kind of get me going in the right direction on the trace toolpath and how to broach it and not drag back up and all of that, right? So you can see that all of these sketches are properly constrained for me, right? They're constrained enough so that we can adjust and drive the sketch predicated on what we want it to do. So we're coming in, we're starting 0.1 off the top of the part so that the machine has time to accelerate. We're broaching down to the halfway point of this slot down here. So this slot's roughly 47 thousandths tall, and we're using a little Harvey tool to undercut so that as we broach, the chip has a place to break off, right? You can't just broach something and hit the bottom of a floor because you're just going to build up a bunch of chips and you'll ultimately break your broach. When I met with Devin, right? Devin's like their Fusion subject matter expert, and that dude legit is, right? He was like, this is going to be tricky because you're going to have spindle feeds to kill. You're going to have all this or RPM and all this other stuff to like deal with as you're trying to go across all these 4 holes. So then I was like, well, I might get a macro made broaching macro. And then I started to get the broaching macro made. And then I realized that was going to take a little bit too long and kind of the barrier to entry there was going to potentially be higher, right? And just take longer because of the learning curve that it would take on my end. So then I reached back out to DSI and I was like, well, hey, can we just mod a post so that out of Fusion, it's broaching and I don't have to do a bunch of hand editing to this code? And they were like, yeah, let us give it a go. Let us try, right? So we come in, we broach. At the bottom, you'll see that we move up 20 degrees and we move up and back out of the way. That way we're not back dragging our broach across the aluminum. So we're taking 1 thou cut at a time. We're moving at 250 surface feet per minute on that broach. So we do it 6 times per hole. And then so now that you kind of see this sketch and how we set that up, and I will show you the actual pattern. So you can see all those lines, boom, boom, boom. You can see we got to come way up high, so we clear the part as we move over to the other holes. And yeah, so I guess some details on how we created this, or how DSI created a post that would allow us to broach. So we'll go into this tool path. We hit edit, and you'll see up here a post properties box that you wouldn't normally see. So we click that, and you can see that we have a box for spindle orientation and to use the spindle orientation. So 6-sided hex, right? 0 degrees, 60, 120, so on and so forth. Super cool, super easy to use, right? The advantage of this is, I guess I should also note that in this tool path, when you do that, when you set an orientation and you lock the spindle, so how it reads in G-code, which I'll show you guys, it would be like your standard M19, and for the Robodrill specifically, it would be like S0, and that's my first starting point of that broach. What it does is it kills the spindle speed to 0 and does all of that. So I'm not going back in and hand editing 85,000 lines of code to get these 4 holes broached. And I can still update. So from going from 33 on my pattern, I'll show you. Going from 33 step overs, we could go to 34 step overs. We could go backwards. We could go to 32 step overs, so on and so forth. So you have a lot of control, very much like a macro, right? The advantage of using a broaching macro is you have control over it. Here we have the control. There might be more inputs, right? But I do believe that at $750 for this post modification, that's the cheapest way and the fastest, in my humble opinion, to get going on a broach like this. So you'll see here on line 24, it calls the M19 S0's the degree orientation. So 0 degrees on my spindle. There's no spindle speed. I didn't have to hand edit any of that. So then, you know, this happens 33 times. We'll just scroll through it very quickly. Ba, 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 ba. And you will see that the degree, right, changed. So we went from broaching at 0 degrees to broaching at 60. So again, I didn't have to hand edit any of this, and we get a total of, 7,957 lines of code that's good to go straight out of their Fusion post for broaching, which is just super slick, super cool. And that's the huge advantage, right? You got a whole company behind you who's going to help get you to the ultimate end goal that you're trying to achieve as a modern day job shop in America, right? Trying to compete globally in this crazy fast-paced market. So with that all being said, let's go broach some holes in aluminum on the Robodrill. So this is really funky because typically you hear a spindle spinning when a machine's running. And in this case right now, we've already done the pre-machine work up to the point of broaching. And I'm just going to show you the broaching because that's kind of the point of this video today, is us just focusing on that. So go ahead and turn coolant off. Since we've kind of been down this rabbit hole of broaching, I've been searching the internet for people single point broaching in a mill, doing stuff like this, and I haven't been able to find anything. This might possibly be the coolest broaching video on the internet, guys. I don't know. But if you know of any other cool videos, I mean, there are other cool videos, a lot of lathe broaching videos, right? Stuff like that. But in terms of single point indexing through CAM, through a post processor, right? I couldn't find anything on the internet. So, but if you know of one, let us know. I'd love to watch those videos. So you can see here that our oil flows a little bit better this video than last video. We made some small changes to the tank that's allowing us to run a little more efficiently, get a little bit better flow, but we still got a little bit of work to do, a lot of work to do on the coolant tank, but That's all to come. All right, like always, pulling it out. First time, seeing if our tolerances are right. It's a little snug. So because this is a little tight, right? A huge advantage to us having a post-processor where it's kicking out code that we don't have to hand edit. I can go back in there and tell it to step over another couple thousandths of an inch to make sure that I have the clearance I need for this. And then because it's not oriented correctly, all I have to go back in there is type in one number change, and it's gonna start the orientation of this broach. It's gonna clock at 30 degrees, and then it will be parallel like the way that I want it to be. So super cool, super happy with this first part coming off the machine like this. You know, very rarely do I ever, well, sometimes I hit the parts right the first time, but on something like this, broaching, something we've never done before, super pumped with the results. And again, just being able to use Fusion 360 and do that is a huge advantage. Some other little detail here is that there is a snap ring groove in there, and if the nut in theory fit down in there, then this snap ring groove would go in and captivate those nuts.
Yeah, carpe these nuts.
So that when it's upside down, those 4 nuts can't fall out. So that's just a little detail of the design of this part, but we're super close. We're gonna dial it in, and that'll be the finished product right there. It'll have 2 pins, the nuts, the snap rings, the bolts. Thanks for watching along today, guys. Really, if I can drive home one point in today's video, you have to partner with quality vendors that are gonna support you and be yes men, right? Hey guys, I need this. They're gonna say, hey, let us find a solution, right? Let us help you. Let us guide you in the right direction so that you can accomplish your goal. You can keep your clients happy. You can make quality parts. And you can get them out the door. It's wildly important in today's fast-paced job shop world. Thanks for following along, guys. I appreciate you. I love you. Having a great time. Thanks, guys.